Alright, we'll be starting chapter 9, area of parallelograms and triangles. Okay, before that, let's do a small exercise here. What we're going to do is we're going to find out which diagram, right, or as you can see, have the same base and between the same parallel. So between the same parallel, that means simply if they have the same height. Clear? All right, let us first have a look at this. So when you look at this, the first figure, you can see that there's a triangle and also a trapezium, right? Now when you look here, can you see that they have the same base here? CD is the same base, right? And remember, height. Okay, when you look at the height of the triangle, this is the height, right? And of course, when you look at the trapezium, this, which means, can you see that they also have the same height or the same parallel? Okay, now have a look at this, the second figure. You can see two more quadrilaterals, right? And if you look at them, you can see that they have the same base here, SR, but do they have the same height or the same parallel? No, right? Because see, for this SM and R, this is the parallel or the height, but for the other PQRS, this is the height. Okay, so of course this diagram has the same base but not the same height. Okay, now let us go to the next here. Once again, you can see a triangle and a parallelogram, right? So if you look here, they have the same base here, RQ, right? But do they also have the same height? When you look at the triangle, T is the height, and when you look at the parallelogram, S and P, which means they also have the same height here. Okay, let us look at 4 now. So once again, a triangle and there's another quadrilateral, right? ABCD. Do they share the same base? They don't, right? Because see, for a triangle, the base is from here till here, but for a parallelogram, it is from here till, for a parallelogram or a quadrilateral, from here till here, right? Of course, they have the same height here. Okay, they have the same height but not the same base. Clear? All right, now let's look at this 5 again. So once again, two diagrams are there. All right, so they share the same base. Okay, this automatically become your base, but do they share the same height? If you look here, the height first for this is the first, right? And then the other height is this. Okay, so they also have the same height. Clear? Now have a look at this again. Do they share the same base and height? Maybe they don't share the same base, because no matter which way you look at it, for the first base it will be only till here, right? And the second base is from here till here. Of course, let's say for that they share the same height, but they don't share the same base. Okay, it's important because the next theorem will be based on this. Okay, so just get the understanding of how to look at the height and the base. So in a question, they will give us same parallel. Okay, so just understand that it means the height. Okay. All right, so let's do the theorem here. Parallelograms on the same base, and then between the same parallel. That means they'll have the same base and the same parallel are equal in area. Okay, so look at this parallelogram here. Can you see the parallelogram ABCD? ABCD, and the second is this, right? Let's go with EFCD. Okay, you can see that inside there are two parallelograms. Do they share the same base? They share, right? This is the same base, and also the same parallel means same height. Okay, so whenever you see two parallelograms having the same base and the same height or the same parallels, okay, the area will be equal to one another. All right. Okay, now what happens if a parallelogram and a triangle have the same base and same parallel? Okay, so you can see here that the triangle will be taking is this. Okay, and a parallelogram they will be taking is this. Clear? All right, so now when you look at the diagram, can you see that the triangle and the parallelogram have the same base? The base is AB. They share the same base AB, and also they have the same altitude, right? For a triangle, this is the altitude. For a parallelogram, this and this. You can see they share the same height, or they are between the same parallel. Okay, so whenever the question says that they have the same base and the same height or the same parallel, remember that the area of triangle should be equal to half times the area of the parallelogram ABCD. Clear? All right, let's do one question from here. In a given figure, ABCD is a parallelogram. Obviously, you can already see here, right? ABCD is a parallelogram, and then AE is perpendicular on DC. That means this is 90 degree, right, on DC, and also they've given us a CF is perpendicular on AD. Okay. Now, if you go back to the question, they've given us a length also. AB is 16, then AE is 8 centimeter, and CF is 10 centimeter. We also find this side here. Okay, so this question, how will we do? I will first try to find the area of this parallelogram. Okay, we'll try to find the area. And what is the formula for area of a parallelogram? Base into height, right? So we'll consider first this to be the base. Okay, and is there height? Yes, there is the height here. Clear? So we'll first find the area of this parallelogram ABCD. And of course, you know that in a parallelogram, opposite sides are equal, right? That is why you can see here AB equals DC. If this is 16, even this has to be 16, right? So our base is 16. Okay, so now let's find the area of the parallelogram ABCD. See, we have to do 2 times here. Okay, first we'll take AE to be the height, all right, and the second time we will try to take, when we try to find AD, we'll take CF to be the altitude. Okay, so I'm taking ABCD with height AE, so this becomes the height, and base becomes this CDF for the first. All right, so like I said, what is the formula for area of a parallelogram? Base into height, right? Base is CD and height is AE. Okay, so we know about the value, you multiply, we're going to get the area of this parallelogram to be equal to 128 centimeter. All right, now the second part, once again we'll try to find the remember AD, right? So this time we'll change the height and the base. Okay, like I said, now the height will become this, CF becomes the height. Okay, that means automatically base becomes this AD, right? And remember, when you look here, I've written the area to be equal to how much? 128 centimeter. Why? Because we already got it formatted. Area of this parallelogram is how much? 128 centimeter, which means, remember, even here nothing changes, right? Because this is the same parallelogram. Okay, so our area will be still 128 centimeter. So once again, if I try to find the area, it will be base into height, right? Then base is how much again? Now base is, remember, this becomes the base, right? And then height is CF. Okay, so now 128, right? Remember, I'm trying to find this AD, and if you look at CF, what is the value of CF? CF is 10 centimeter, right? So I put the value here. This 10 will go down to the denominator. When you divide, we're going to get it from here. AD, the value that we're asked to find, this AD is equal to 12.8 centimeter.